China's power grid is about to do something that should not be physically possible. This summer, the country's peak electricity demand is expected to hit around 1,600 gigawatts. That is not a typo. To put that in terms you can actually picture, the increase alone, just the extra load added compared to last year, comes to roughly 90 gigawatts. That single year-over-year jump is close to the entire peak electricity demand of Henan province, a place with almost 100 million people, all added onto the grid in the space of 12 months. Here's the part that should confuse you. China is not responding to that number by racing to pour concrete for a new wave of power plants. Instead, the country is quietly assembling something that has no smokestacks, no turbines, and no address. Millions of air conditioners, home batteries, factory production lines, and electric cars, all wired together through software, snapping into formation for the exact minutes they're needed and acting like one enormous power station. It is called a virtual power plant, and Chinese regulators want it supplying more than 50 gigawatts of capacity by the end of the decade. That is more generating capacity than entire national grids run by G20 economies, built without a single foundation poured. Before you get too impressed, stick with me, because this story does not start in China. It starts with a small, half-ignored experiment in Germany that almost nobody in the energy industry took seriously, and a flaw sitting inside the very power grid that is keeping the device you're watching this on charged right now. If you want to actually understand how the world's energy systems are being quietly rewritten while nobody's paying attention, this channel breaks it down every week, so it's worth hitting subscribe before we get into it. For most of the last 100 years, every electrical grid on Earth ran on the same basic idea. You build a small number of very large power plants, coal, hydro, nuclear, gas, and you connect them by wire to homes and factories that could be hundreds of miles away. Power moved in one direction only, from the plant to the customer. And the entire job of the utility running that grid came down to a single responsibility. Build enough generating capacity to cover the worst possible day of the year, then keep it sitting there, waiting. Here's the detail almost nobody talks about. This model was never really questioned because there was no alternative. Electricity could not be stored at any meaningful scale, so supply had to match demand in real time every second of every day, or the grid would fail. The only lever available to an engineer was size. Build a bigger plant, build another one next to it, add more steel, more concrete, more turbines, and hope you guessed the peak correctly. China adopted this model and then took it further than any country in history. Between the 1990s and today, the country built out generating capacity at a pace that had never been attempted anywhere else, chasing an economy that was industrializing and urbanizing faster than the grid itself could keep up. Entire provinces got their own dedicated coal fleets. Entire river systems got dammed for hydropower. And running underneath all of it sat the assumption that had defined electricity for a century. If you need more power, you build more plant. That assumption worked, right up until it started breaking under its own weight. To understand how far China took the old model, look at the pace of construction alone. It took the country roughly 8 years to go from 1 trillion watts of installed capacity to 2 trillion. It took less than 5 years to go from 2 trillion to 3. Getting from 3 trillion to nearly 4 trillion took barely 2 years. By the first quarter of 2026, China's total installed power generation capacity had reached close to 3.96 billion kilowatts, according to the National Energy Administration. That is almost 4,000 gigawatts sitting on one national grid, roughly 30% of all the generating capacity on the planet, and about 3 times what the entire United States has built. And it doesn't stop there. The country backed that construction with money on a scale that is hard to hold in your head. In 2025 alone, China poured roughly $500 billion into major energy projects, a record for any country in a single year. Over 430 gigawatts of new wind and solar capacity went up in that same 12 months, which by some estimates is close to 8 times what the United States managed to add. State Grid Corporation of China, the utility that runs most of this system, now serves more than 1 billion people directly, making it the largest utility on the planet by a wide margin. Its ultra-high voltage transmission lines, some like the Hami to Chongqing corridor, push electricity across thousands of kilometers at 800 kilovolts, moving power from remote deserts to megacities most of the country will never see. This is not a grid. This is the largest machine ever assembled by human beings. And buried somewhere inside that machine, even at this staggering scale, was a flaw that sheer size could never fix. Here's the honest reason bigger was never actually the same as better. Somewhere in every grid on Earth, including China's, sits a category of power plant built for one single job, standing by for the handful of hours a year when everyone turns their air conditioner on at once. These are called peaker plants, and manufacturers like Siemens Energy and GE Vernova, who actually build the turbines, are upfront about how little these plants work. Most run for fewer than 2,000 hours a year. Some run for as few as 250. In the United States, peaker plants account for close to 1/5 of all generating capacity, yet they produce barely 3% of the electricity that actually gets used, because their entire purpose is to sit idle almost every day of the year and then fire up for a handful of sweltering August afternoons. It gets worse. China's own coal fleet, the backbone of its grid for decades, has been quietly sliding into the same trap. Analysts at Wood Mackenzie found that Chinese coal plants ran at around 60% of their potential output back in 2011. By 2025, that figure had fallen to about 48%, and it's projected to keep sliding toward roughly 32% by 2035 as more of the fleet gets pushed into standby duty. And yet, construction never stopped. China broke ground on 83 gigawatts of new coal capacity in 2025 alone, essentially building trillion yuan insurance policies that spend most of their life doing nothing. That is not a small inefficiency. That is the entire logic of the old grid quietly falling apart plant by plant, even as China kept building more of it out of habit. The first real challenge to that logic did not come from China. It came from a small piece of academic theory almost nobody in the power industry took seriously. In 1997, economist Shimon Auerbach published a book called The Virtual Utility, describing a strange idea. What if a grid did not need one giant power station to act like a power station? What if a scattered collection of small, unrelated generators, none individually significant, could be stitched together with communications technology so they behaved as a single unit? At the time, the computing power to pull this off did not exist, and power markets were only just opening up to anyone but a giant utility-owning generation. The theory sat mostly unused for over a decade. Germany became the place where it finally got tested, and not because German engineers were chasing something futuristic. They were stuck. The country's Energiewende, its national push toward renewables, had scattered thousands of small wind turbines, biogas units, and hydro plants across the countryside, each one too small to matter on its own and too unpredictable for a grid built around a handful of giant steady power stations. In October 2008, the German utility RWE flipped the switch on what it called the world's first virtual power plant. It combined 9 small hydroelectric stations, ranging from 150 kilowatts up to 1.1 megawatts each, into a single coordinated unit with a combined capacity of just 8.6 megawatts. Next to Germany's gigawatt-scale coal fleet, that number was almost embarrassing. Nobody took it seriously. It looked like a science project. But that tiny pool of hydro plants was about to prove the entire industry wrong about what actually counts as a power plant. Our WE's experiment did not stay small for long, because it answered a question the rest of the industry hadn't even known to ask. If you could coordinate 9 hydro plants, why stop there? Researchers in Germany followed up with a project called Kombi-Kraftwerk, combining solar, wind, biogas, and hydro assets, and controlling them in real time to prove something that sounded almost like a stunt at the time. At a scale of 1 to 10,000, they showed that a 100% renewable power supply could reliably match demand around the clock. A private company called Next Kraftwerke, founded in Cologne the following year, took that proof of concept and turned it into a business, eventually pooling thousands of small generators into portfolios that could compete directly with traditional power stations on Germany's electricity market. Meanwhile, the United States arrived at a similar idea through a completely different door. Not renewables integration, but old-fashioned demand response programs that paid large industrial customers to power down during emergencies. 2 separate paths, one European, one American, circling the same conclusion. You don't always need to build more power. Sometimes you just need to coordinate what already exists. China noticed, but quietly. The earliest pilots showed up around the mid-2000s in Shanghai in Jiangsu province, small enough to be genuinely unremarkable. A handful of factories agreeing to shut down non-essential machinery for an hour during a heat wave in exchange for a modest payment. Against a national grid pushing toward 4,000 gigawatts, these programs were a rounding error, easy to miss entirely. That was about to change, and not because China discovered a new source of electricity. It changed because China discovered a new way to conduct the electricity it already had. Here's where it gets interesting. For decades, the engineers who ran grids the size of China's assumed something so basic nobody bothered to argue about it. A system serving 1.4 billion people needed physical iron. Heavy spinning turbines with enough mass to hold the grid steady second by second. Name the actual obstacle, and it's a brutal one. China's grid has to hold its frequency within a razor-thin band, balancing generation against demand in real time across a country spanning 5 time zones worth of geography. Coordinating millions of scattered, unpredictable devices to respond in the same instant was considered close to impossible with the communications technology available even 10 years ago. So what if the actual problem was never a shortage of generation? What if the real problem was coordination? Picture an orchestra scattered across an entire country, every musician alone in their own living room, never gathered under one roof. Instead of building a concert hall, a conductor slips a single earpiece to each one and cues them to hit the exact same note within half a second of each other. Nobody moved a single instrument. The music still arrived whole and on time, because the coordination did the work the concert hall used to do. That is what China's virtual power plant software does with air conditioners, batteries, and factory equipment scattered across entire provinces. In January 2025, Jiangsu Electric Power, a state grid subsidiary, switched on China's first gigawatt-scale residential virtual power plant, using big data, IoT sensors, and AI to pool millions of household appliances into one dispatchable resource. Months later, the National Development and Reform Commission and National Energy Administration set a national target: virtual power plant capacity above 20 gigawatts by 2027, above 50 gigawatts by 2030. Hit that second number and China's virtual power plants alone would outsize the entire electricity grid of a country like the Philippines. But getting there means solving problems that have nothing to do with software. Before you get too excited about a country quietly out, engineering its own power plants, there's a catch, and it's worth being honest about the limits here. Start with scale. 50 gigawatts sounds enormous until you set it against the roughly 1,600 gigawatts of peak demand China is expecting this summer. Even hitting the 2030 target puts virtual power plants at somewhere around 3% of peak load. That number sounds impressive until you remember it is a patch on the system, not a replacement for it. Then there's the vehicle-to-grid problem. China's National Energy Administration projects that electric vehicles could eventually supply up to 50 gigawatts of dispatchable capacity, but not until 2032, 6 years from now. As of early 2026, the country was targeting just over 5,000 new bidirectional charging points by 2027. A tiny fraction of the more than 20 million public and private charging facilities already installed across the country. The hardware that lets an EV sell power back to the grid is still closer to a pilot program than a standard feature. That is not the whole story either. The participation itself is not guaranteed. The math only holds if millions of individual households and factories keep opting in year after year, in exchange for payments that local grid operators can adjust or cut at any time. In Zhejiang province, one paper mill reported receiving roughly 840,000 yuan for participating in a single week of peak shaving. That is real money, but it is also a subsidy, not a law of physics, and subsidies can change. This is not proof that China has already solved its power problem. Coal capacity is still being built, not retired, which means the virtual power plant is running alongside the old model, not yet replacing it. This is not a lab claim anymore, this is real, and it happened this month. In early August 2026, a heat wave pushed power demand across northern, northeastern, and eastern China to record highs. State Grid Corporation reported record electricity loads across its networks in Hebei, Tianjin, Liaoning, and Shandong within the same 48-hour window. In neighboring Anhui province, the local energy bureau confirmed peak demand hit a record 69.99 million kilowatts, up 2.1% from the year before. Here's what the headlines missed. According to Xinhua's reporting from mid-August, grid operators across China faced this summer's demand peak with noticeably more confidence than in previous years, crediting a combination of long-distance ultra-high voltage transmission, battery storage, and virtual power plants for keeping the lights on without the rolling blackouts that had haunted earlier heat waves. In Wuhan, a new pricing pilot that began on July 1st let electric vehicle owners charge during off-peak hours and sell electricity back to the grid during the crunch, earning extra income while helping flatten the demand curve. And on the exact day this heat wave was breaking records, State Grid's Changzhou power supply company ran a full-scale live dispatch drill, coordinating 13 public vehicle-to-grid stations and 8 battery swapping stations at once. 208 electric vehicles discharged a combined 19,000 kilowatt-hours back into the grid during peak hours, in a real-time test of exactly how far this coordination can scale. None of that came from a research paper or a company press release full of promises. It came from a national grid operator under real heat on a real day, choosing coordination over concrete. And the moment other countries realized China had actually pulled this off at scale, the race stopped being a Chinese story at all. Let's zoom out for a second, because China is not the only country watching this play out. The United States Department of Energy already counts somewhere between 30 and 60 gigawatts of virtual power plant capacity operating on American soil, and wants to triple that to somewhere between 80 and 160 gigawatts by 2030, projecting savings of roughly $10 billion a year in avoided grid costs. Industry researchers expect the global virtual power plant market itself to grow past $31 billion by 2035. So where does this go from here? A few predictions worth sitting with. 1. More Chinese provinces move from voluntary pilots to mandatory participation for large industrial power users, turning today's cash incentive into tomorrow's regulatory requirement. 2. Bidirectional charging stops being a rare feature on Chinese electric vehicles and becomes standard as automakers race to unlock the vehicle to grid revenue their competitors are already chasing. 3. The real competition among the world's grid operators shifts away from who can pour the most concrete toward who can write the best dispatch software. 4. Coal utilization in China keeps sliding even as new plants keep getting approved, turning much of that fleet into an expensive insurance policy rather than a daily workhorse. 5. Grid operators in the United States and Europe accelerate their own virtual power plant rollouts, worried about losing this exact race to a country most of them still picture as running on nothing but coal. So here's a question for you. If your own air conditioner, your home battery, or your electric car could quietly earn you money by helping stabilize the grid during the worst heat wave of the year, would you opt in without hesitation, or does handing that kind of remote control over to a utility company cross a line you're not comfortable with? Let me know what you think in the comments. And if you want to keep watching how the world's energy grids are quietly being rewritten in real time, the next video is waiting for you right now. Subscribe before you go.